Okay. So Kartik suggested. So I just want to go through a few items on Blackboard. So my email and the Calendly booking link, it's in the syllabus, but the syllabus is also here on Blackboard if you need it at any point. If you have a general question about the course, I've created a thread on Blackboard where you can ask questions, and that's just, maybe it's a good idea to check that forum regularly before you ask a question in case someone else has asked it and I've already answered it. That way I don't get a dozen emails all asking me the same question. Under faculty info, again, you can find my email address here. Here's my LinkedIn profile, and then the Calendly booking link is really simple. So if you haven't seen Calendly, probably most of you have. You just go here, pick the day, and you can click on a time slot, and then it will ask you to put in a description of what are we meeting about so that I can come prepared. So good that if you fill in a description there as well. So happy to connect with you on LinkedIn. I know many of us are already connected. This is also a great way for us to stay in touch once you're out working. It means, I can keep tabs. We like to keep tabs on what you guys are doing, and we like to stay in touch. A number of our former students have come back to Georgian as teachers. In fact, I think, Hayden went through the program his first 2 years several years ago, and a number of Hayden's classmates have been teaching in the program for the last few years. Actually, I just reached out to a student who graduated from the program last year. I had given him a job reference, and I just wanted to check in with him and see how he's doing. And he's actually going to come back to class and do a guest talk in one of my classes in January. So we do also have a program LinkedIn group. So I'll maybe just show that. So many of you are members already. But it's a pretty active group, and we post kind of relevant content, also a lot of job opportunities and things like that in here. So if you're not a member, you can just search for the Georgian Computer Studies group. So it's unlisted, so you do have to request access to it. But wherever we see jobs, so Brad, who's a grad of computer programmer, his company, Lean Labs, is hiring a digital marketer. So he posted here, so I shared. So we post things that are going on in the industry. We post things that are going on in the campus on the program, and lots of jobs. So I'm going to strongly recommend that you join the group. And it's not only for current students, but it's also for alumni. Maybe many of you, once you're out working in a few years, either you're going to want to change jobs, or you're working in a management role and you're looking for people. So this is a great place to kind of stay connected to your classmates and peers and faculty, not only during your time here, but also when you graduate and move out into the workplace, as you guys are all going to be doing over the next year. Okay, so I encourage you to have a look at that group. I know a number of you have already been members of that group for quite a while. So inside of Blackboard, so we'll have lesson folders for each week, and then tools and resources. Yeah, absolutely, Andrew. Happy to be added on LinkedIn. This is really the only social network that I use. I've deleted Facebook. I have Twitter, although I don't really use it. I don't use Instagram. I don't use Snapchat. I use LinkedIn for professional purposes. So it's a great way for us to stay in touch. Yes. I highly recommend. I actually just wrote a paper on the book. You want to know how Facebook and Google really work? Check out this book. She's a professor at Harvard, Shoshana Zuboff, who wrote The Age of Surveillance Capitalism. talks all about, you know, this whole notion of how that basically works. It's not only that we're the product, but that these companies traffic in predicting our future behavior, and that's how they make their money. So on tools and resources, so here's the you know, just the WebEx link. So if at any point you forget how to get back in the room, you can find it on the syllabus, but it's also in tools and resources. I do have a playlist on YouTube. So I have one for every section for every semester. So even if you want to watch some of the lessons, you know, you're curious about what authentication looks like in Android, you can go and find the playlist from fall 2019 and check out that lesson. So if you want to, you know, give you some idea of what those playlists would look like by the end of the semester. So each hour of class, each time we take a break, I'll stop and create a new video. So for most lessons, we'll have 2, sometimes 3 videos. So for example, here's the video playlist from this class for last fall. So I had 2 videos, roughly an hour and a bit each for each class. So all the videos are public, which also means, you know, sometimes I even have students after they've graduated, but they want to learn a skill that maybe they didn't study when they were here. So, you know, my videos are public forever, so you guys can continue. Yeah, the link is here, Kartik. Right here, this class screencast YouTube playlist. This is for our class. So the lessons for our Friday class this semester, they'll be right here. Oh, well, all you have to do, so if you just follow this link, this will take you to our class. So to get to the previous ones, Kartik, just click on my name, and that'll take you back to the channel. And then here we are under playlists. So these are all the playlists. I've actually been recording for, I think since 2015, I've been recording the lessons. So again, just from our playlist, just click on my name. And then playlists gives you everything. So for those of you who took PHP with me, fall 2018, I think it was Fridays. Those are our PHP lessons. So everything I do, you can basically see every class I've done for the last 6 years, and I will just continue to do this. Yeah, this was actually the idea of Tom Siliopoulos, who used to teach in the program. I think, Hayden, you would have had Tom years ago. Tom's now teaching at Centennial and George Brown and Seneca, as well as Ontario Tech. It's a long drive for, yeah, Delano, you would have had him. A long drive for him because he lives in the city up here. So Tom was the one who sort of pioneered the idea of, hey, let's record everything and put it all on YouTube. So I followed Tom. So everything is here, basically every class I've done since 2015. So it will always be here. If you want to check out my classes 5 years from now, just come to my channel. They'll be here. Okay. Everything we do in class will be on GitHub. So I've just given you a link to my GitHub page. So again, previous repositories from previous years of the class from my other classes, they're all here. And at the end of class each week, I don't think I'll upload today's Android Studio project, but we're going to set up a project and work on it every week starting next week. And at the end of class each week, I will upload, make a new commit with those changes, describing those changes. So just to show you what this might look like. So last year we made like a little music library app. So in each class, often when I would take a break, I would just, like lesson 8, part 1, and I'd make a new commit. And then at the end of the second hour, so I put in descriptive messages. So if you need to grab any of the source code from GitHub, I will do this where we'll just keep adding on to the same repository each week, and I'll descriptively kind of link the changes to each lesson. So if you miss one lesson or part of a lesson, you'll know which commit to go and check for the code that you need. So that link is here. Again, the office hours rules, and just some general resources around Android. So links to the developer documentation. We're going to use Firebase. So Firebase is Google's cloud NoSQL database. So we're going to use that for data storage later in the semester. And then some links to some of the Google design resources. Oh, that's great. So you know what? If you've used Firebase, yeah, you may have some knowledge that you want to share. You may have some tips and tricks to make our Firebase usage better. Git is integrated right in to Android Studio, but I always like to throw up the push command, the commands here to create a repository and make a commit and push your code to GitHub. So those are kind of general things that are in tools and resources. So, you know, the playlist and the GitHub links are going to be the things you commonly need. So if you are learning asynchronously, then for sure you're going to, you know, find each lesson, the lesson videos on the playlist, and you'll find the source code on the GitHub repository. So in the lesson one folder, I'll try to set out for each week, you know, the objectives of what we want to do. So we've kind of done the first part, you know, through the forum and my introduction. We know a little bit about each other, and those of you who put your cameras on, we're going to talk about Android and Kotlin, and then we'll just kind of open up Android Studio and play around a little bit. I'll also try to put a little checklist in each folder. So before next week's class, by next Thursday, these are the things, you know, you should have introduced yourself in the forum, completed the academic integrity pledge, set up Android Studio, and then participated in our little whiteboard activity at the end of class. Followed through our little lesson demo in Android Studio, which we're going to do, and then completed your week one quiz. So these are all the things you should have done, should do by next Thursday. Okay. And I'll try to add one of these checklists so that you know exactly what you need to do each week. So let's talk a little bit about Android kind of at high level. Actually, before I open this, how big do you think Android is? What share of the mobile market do you think Android has around the world? Obviously, it's different in different countries. We're thinking 70%, 89, 60. Okay, so everyone's saying more than half. 65. Yeah, okay, that's a good range. So let's check out the current stats and see what they're telling us. Ooh, so this is as of August, according to statcounter.com. Here we are. Globally, there's Android. So 74%, 74.25% as of August. So an iOS would be about 25%. And then we have a few random other mobile operating systems. Obviously, this changes. I think if we're not looking worldwide, if we're looking like in wealthier countries, we'll probably see the iOS and Android market share closer, but Android is absolutely the dominant player, largely due to its open source nature and its cost. So you can put an answer in the chat, or you can turn on your mic. So let's make a list. What are all the devices that we could run an Android app on? I'll just add a list. Yep. We're on laptops, phones, TV, yep, no one's mentioned yet. Yep, vehicles. I was just about to say the most expensive device that runs in Android. Yep, TV box, Android TV, absolutely. Yep. So we've got this massive kind of ecosystem that's only growing. So things like home security. What other devices do we typically see on the wall inside of a home? A lawnmower? I didn't know that, Andrew. Yeah, thermostat. Yep, gaming consoles, stations consoles. Yep, Google has a thermostat. Or I'm not sure. Yeah, smart glasses, Google Glass. That's a good question, Nadia, about Alexa. We'll have to look into that. I'm not sure whether that uses Android. I think it does. I don't think there's a proprietary OS on that, but we should find that out. Really, Manuel, an F18? Yeah, so really any sort of appliance. Can run Android. So it's everywhere. So, we're going to sort of focus on designing for phone, but the apps that we build, really could be deployed to all kinds of different devices. And this list is only going to grow. Just move my little window over here, and I'll update this item on Blackboard. So Android was actually created as a separate company. So Google bought it. Google buys up lots of companies a couple years after its founding, and so and this was a couple years as well before Apple came out with the iPhone. So the first Android phone came out back in 2008, and within 6 years, Android was there were a billion Android phones shipped out a year. And then also in 2014, Google started looking at expanding beyond phones. And I'm not even sure this slide's a little bit dated, but there were over 2 million apps in the Play Store as of 2016. I'm not sure how many there are now. Certainly going to be more than 2016. And by the end of this semester, there's 37 students in the class. We're going to have at least 37 new apps published in the Play Store, and every one of you is going to have your own app in there. So that's kind of a quick view of Android. I do want to look also a little bit at the Kotlin language and what this is. I'm not a huge PowerPoint guy, but especially because we're not learning in person, I'll try to create, at least a brief slide deck that you can use for reference and post these to Blackboard each week. So this intro to Kotlin, this is the slide deck that we're just going to kind of run through quickly right now. Okay. So Kotlin, for years, Java was the default language of choice for Android development. And years ago when this course was taught, usually the students used Eclipse as the IDE, and they coded in Java. So Kotlin came along a few years ago, and it was actually created at JetBrains, so the makers of the IntelliJ suite and some of the other IDE products that you would have used here at George, and things like, many of us used PHP Storm in our Intro to Web programming class. Probably many of you used WebStorm in your JavaScript frameworks class. So Kotlin compiles to either the Java virtual machine or JavaScript. It is open source, and it's fully interoperable with Java and all Java frameworks and libraries. So this means in a Kotlin file, we can actually include both Kotlin and Java code in the same actual file. They're fully interoperable. So some of the benefits of Kotlin and some of the reasons that it's taking off, the syntax is lighter. So to write the same code in Kotlin, we're doing less coding than we have to do in Java. That saves us time, it reduces errors. It has a much smaller runtime overhead than Java. It's well supported in Android Studio. So if we look at the developer documentation for Android, we'll just pull that up quickly. What you'll see is that all the code samples are actually given in both Java and in Kotlin. So if we want to go to, let's see. We can just. So they have the API reference for both Android and Kotlin. And many of the topics kind of, let's just go into the, for example, the layout. So typically, so we can toggle, for a lot of the documentation, it has the both in Java or in Kotlin. So we may see this. So some of it is only available in one and not the other. One of the other big things about Kotlin is the way it deals with nulls. So one of the most common problems with Java development are null pointer exceptions. So Kotlin handles nulls in a different way, and it catches catches a lot of null pointer errors at runtime. Sorry, at before runtime, at compile time and at coding time. So we get a lot fewer null pointer exceptions when we're developing with Kotlin. Kotlin also supports asynchronous programming. It's kind of a built-in feature to Kotlin, and a lot of you are familiar with asynchronous programming with JavaScript from your JavaScript frameworks course. So Kotlin allows that one process to run on a thread while another process is executing. So for example, here, if we want to look side by side at the code and see Kotlin's more lightweight syntax. So if in Java, we declare a variable of type string builder, we use the new keyword. So in Kotlin, we just use val for declaring variables. We don't have to declare the type. The types are inferred, much like using var in C#. And we don't need the new keyword anymore to instantiate an object. So these lines are functionally equivalent, but Kotlin is less code, so therefore less chance of errors. No, it's not loosely typed, Hayden. It is strongly typed, as is C#. It's just that the interpreter, it's not that it changes, the interpreter can infer the type. So if we're instantiating a string builder object here, it automatically will allocate this SB variable as a string builder object. Yeah, similar. Really similar to using var like in C#. So var, so there's a C#. So var is still interpreted as a string. It's not loosely typed. It's not an object. It is considered a string because it can infer from the variable we're assigning it to. So Kotlin works the same way. So this means the coding of the variables becomes simpler. We'll just use val rather than having to actually repeat the object names. So again, here's another comparison. So this is kind of be up in gray on my screen. You see sort of like the older Java version. So we have a floating action button. We have to find it in our UI and declare it. And then we would write kind of this messy syntax for a click event handler. We would call set on click event handler and then create a new click listener. And then we'd have to override the click method before writing our code. In Kotlin, this is much cleaner. And in fact, this first line of finding and recognizing the button, we don't even need. Yes, it is. It is, but again, that's kind of the Java syntax in gray, and the Kotlin syntax is lighter weight down below. So we're writing much, much less code. First time I taught this course, we used Java, and the last time I did it, we did Java, and then we did like 1 or 2 lessons at the end of the semester on Kotlin, and students loved Kotlin. And the feedback I got at the end of the semester was, we liked the course, but we know so much Java already. We really wish you had just taught us Kotlin from the beginning. So last time I taught the class, I asked students at the beginning, do you want to do Java or Kotlin? And almost universally, the students said, let's do Kotlin. We've done lots of Java. And Kotlin looks cool. It looks like it's less work, which it is. Yep, no more overrides, exactly. Okay, one of the other real kind of cumbersome things about doing Android with Java, and if you look at old Android tutorials, you'll see this. You can see it in this code here. So this find by ID, what this means is that the visual elements on our Android screens, those objects weren't immediately available in the coding window. We had to reference them by calling find view by ID and referencing the ID of each object before we could program against it. So with Kotlin, there's an automatic library called Android Synthetic that automatically ties any visual elements like buttons or images into the code. So we no longer have to write these find view by ID statements to interact with every visual component on our forms. So Kotlin is getting used more and more. So these are some really popular Android apps that are using Kotlin. So Android Studio, it applies a Kotlin Language plugin. So you can see it down here underneath the yellow. We've got a dependency on the Kotlin library, and that allows our project to use Kotlin. And there's also the plugin and extensions are applied up here at the top. So a few other things about the syntax. We don't require semicolons to terminate commands anymore. You can put them in, but you don't have to. Tim, as you mentioned in the chat, yes, we don't need to override the event handlers. That now happens automatically. We've got the fun keyword for functions. And then we just use declare variables basically as val and var. So val meaning a variable is immutable. The value can be set once and it can't be changed. So basically we use val for constants and var for mutable. So if we want to be able to write a value and then change it, we're going to use var. And it is strongly typed, but those types are going to be implicit. And we can also use it. We'll play around with some more of these kind of language. Yes, val is like const. We'll actually explore that next week. What happens if we use val, we assign a value to a variable, and then we try to change it. We'll see that the Kotlin, at design time, it's going to complain and say that we cannot change the value because val is immutable. Yeah, same thing. Same thing, Misam, you're right. Okay, so that's enough talking. Let's fire up Android Studio and let's play around a little bit. Let's see exactly how this works. So I'm going to open up Android Studio. One thing to keep in mind, and you're probably familiar with this if from working with other JetBrains IDEs, they update them a lot. So it's not a bad idea before 11 o'clock on Friday that you already open up Android Studio because it seems like there's updates to either the program itself or one of the Android SDKs. The updates come all the time. And sometimes they're large. So it's not a bad idea to make sure that you're keeping your Android Studio up to date. We'll talk about the version. It doesn't really matter. We'll talk about that in a second when we create a new project. Yeah, you don't need to, it doesn't really matter what version of the SDK you use, because yes, some of them are really large. So I don't want you to install a whole pile of the SDKs. I would just install one. So I'm going to make a new project. Now, this is kind of a throwaway project. I'm not going to keep this one. We'll make a new, maybe starting next week or the week after, we're going to build a project, and then we'll keep that and we'll keep working on it every week during class. So once Android Studio is open, the default setting is to open up the last project you had open. But if you have never done one before, this is kind of the opening screen. So what we're going to do is we're going to start a new Android Studio project. And Android Studio comes with a whole pile of templates. So it asks for like a startup activity. So it's got basic, it's got one with a bottom nav, an empty activity where we get absolutely nothing, and then some other more advanced activities like master detail, a login screen, a Google map. For now, we're just going to stick, and also we can choose what type of device. So we mentioned all kinds of devices like Android Auto, TV, wearables. We're just going to stick with phone and tablet, but I'd encourage you to play around with some of the other templates. And I'm just going to pick an empty activity and click Next. We have to give it a name. So I'll just call it F20 Lesson 1. The names typically start with a capital. And notice it creates a package name. This package name has to be unique if you're going to publish your app to the Google Play Store. So you can't have two apps that have the same package name in the Play Store. You can just save it wherever, and it's going to ask you to choose your language. So I'm going to pick Kotlin. And then coming back to some of the discussion around the SDK. So it's defaulting, it asks, what's the minimum version of SDK? So it defaults to API 23, which is Android 6. And one of the useful things Android Studio does is it tells you, every time you choose a version, it tells you what percentage of Android devices will support it. So typically, Hayden, coming back to your question about the latest and greatest, I could pick up to Android 30, but you can see hardly any actual device out there in the wild is going to be able to run that. And if I choose this, I'm going to have to install that version of the SDK. Even if I pick something like API 29, most devices aren't going to be able to use it. So I'm just going to kind of choose the default version of Android 6, which the vast majority of Android devices are going to be able to run. So there isn't really a right and a wrong answer here. I don't know what defaults you guys are getting in the minimum SDK. So mine defaults to API 23. What version does yours default to? Yours is Jelly Bean. Okay. Yep, that's fine. It's really not a problem. So the older, now, some of you are saying 14, 15, 16. Those versions are quite old. We may not want to go quite that far back because there may be some things we cover in class that will be missing from versions like from Jelly Bean versions. So what I would suggest is you may want to pick Marshmallow just because any features that I implement in mine, I know those are going to be available. You know, if you pick version 16 and then we go to do something, it may look totally different if you're in a much older version. So I would recommend that we maybe use Marshmallow and API 23. You don't have to, but it may just make things run more smoothly. Okay, so again, give your app a name. Make sure you choose Kotlin, and I will let you decide what minimum SDK, but probably 23 is a good bet. And then we'll just click Finish. So it's going to set up our project. And we can have a look at what's here. So Android Studio automatically opens 2 files. And we should kind of look at the structure. So it opens two files. The first thing it does is it gives us a startup screen. And in Android, and hint, there's a question on the review quiz about this. Android doesn't use the terminology screens, it uses the terminology activity. So if we have 5 different views in our 5 different screens a user could navigate through in our app, we'll have 5 different activities. And activities can be a full screen, or it can also be a part of a screen. So we're going to look, and we get 2 files. We get an activity main.xml, and then we get a main activity.kt. So this is our Kotlin file. So it includes a bunch of dependencies. And it creates a class that inherits from app.compat activity. And it's got an overridden onCreate method. So what should happen each time an instance of this activity gets created? So what it's going to do is render the layout from our activity main.xml file. So it does do an initial compilation. And we'll have a look at the compile system, the build system in just a minute. So we get this main activity, as well as we get a default XML layout, and it's got a text view that's basically a label that says hello world. So it gives this to us right out of the box. So there's 2 views. So every activity gets 2 files. The XML file that contains the visual layout, and then the .kt file, or it would be a .java file if you were using Java, that contains the code. So these are paired, and we have 2 ways to view the layout. We can view it in the designer view, where we've got a drag and drop editor. We can also go into the code view. So up here near the top right, you can see I've got the design view is enabled by default. If I click on code, we actually have an XML representation of the layout. So we can modify this layout in either view. So if I wanted to, for example, remove this text view, I could highlight and delete the code here, or I could simply go to design view, click on it, and delete it from here. So sometimes we'll probably be working in each. For adding new elements, the drag and drop is useful. For changing properties of elements, sometimes it's just easier to do it right in the XML. That's pretty much your preference. That's a good question. I'm going to talk to that, Hayden. I recommend, so you'll notice over here, here's our project window, and we've got a few options. We have the Android view. Typically in Android Studio, it's helpful to use the Android view. So the Android view and the project view, these are different. If I go to project, this is how the project is actually stored in the file system. So under app, source, main, and then it's divided this way. So even though our folder says Java, this contains our Kotlin file, and our actual layout, our resource, is in under here. Generally, I've found, and most developers find, that the Android view is actually an easier way to navigate. So you can use either view, but I strongly recommend the Android view. So let's look at what's in here. So we have a manifest. So we've got, this is kind of like a configuration file, sort of like your app settings.json in an ASP.NET application. So this is an XML document that has some base properties of the app. So things like the package name that'll get published to the Play Store. It'll have an icon. So this will be the icon that gets shown on the Android home screen. The actual name of the app, which we can change. So it defaults to our project name, but we may want to put a friendlier name here. We can theme it. It also has this intent filter. So what do you suppose this is doing? These lines of code here that I've highlighted, where we've got an intent filter. What do you suppose these lines of code mean? Yeah, basically it's setting a startup activity. So it's saying when our app gets launched, the default activity is the main activity. So if we want to change, we build an app with 5 different activities, we can determine what activity should show. You could kind of think of it like a constructor in a way. Yep. So in our manifest, the manifest is also where your app's permissions live. So for example, when the first time you use an app or when you go to install an app, you'll get a prompt saying this app wants to access, let's say, your phone and your contacts. So those permissions get declared in the manifest. So when we deploy to the Play Store, users can see what permissions the app is asking. And when the app gets installed, it will prompt the user for those permissions. So those things will get declared in our manifest. No, actually, the SDKs go somewhere else. We'll come to that. So even though we said Kotlin, all the source code goes inside. We have a couple projects here. So under the Java folder, you'll notice we have the main project that says lesson 1. We also have unit testing projects. So we get 2 default. We get an instrument test and a unit test. So if we have time to play around with those, we will. But most of our application code goes right here. So if we have additional activities, each one will have their own Kotlin file in here. Or if we set up our own classes, those classes will live inside of this folder. Then we have the RES or the resource folder. So we have different types of resources. We've got drawable resources. So this will be basically icons and images. So we have a default foreground and background. If we have other icons or images in our app, they'll live inside the drawable folder. And these are XML representations of those images. Under layout, these are our activities. So our main activity layout file lives under the layout folder. If we create other activities, we'll have additional XML files here. The mipmap folder, these are for our icons. Yeah, we're going to come to Gradle. Thanks, Kivo. Thanks, but thanks for mentioning that. We'll get there. And we've got different resolutions. So our launcher icon, you'll notice we have 6 different versions because we have users using different screen resolutions. And then under values, we have resource files for things like global colors, string values, or other global styles. So think of this is kind of like the Android equivalent of CSS in a way. This strings file, which we'll play around with, yes, when you create the project, you can just change the package name. It will default to example.com. You just overwrite that value in the package name when creating the project. So strings is also used for multi-language support. So let's say our app is going to be in 10 different languages. Instead of hard coding text values in the app, we would create a separate strings.xml file for each language. So then we come, you asked about the SDK versions and dependencies. So Android uses a JVM-based compiler called Gradle. Okay. So we have 2 build.gradle files. So this one that's at the project level, this describes the Kotlin version and the dependencies. And this one under the module.app, this includes the Kotlin plugin. So here's where we'd find our SDK version. Okay. And it also sets out things like the minimum SDK version and our version code. So when we publish this to the Play Store, it's going to show the minimum SDK version. So it'll tell users, hey, you need 23 or newer. If you're running version, you're running Jelly Bean on your Android device, you may not be able to run this app. Yes, you can just change the name. But that ID has to be unique when it's published to the Play Store. And then we will be adding dependencies in here later. So for example, if we want to connect to a Firebase database, we're going to need to implement a Firebase dependency in here. And sometimes we also have to update the versions as well. So if we build, it will launch the Gradle to try and build our app. So we should actually be able to just run the app as it is. And it should hopefully display in our Android emulator, or if you've plugged your device in, it should run on your device. I just need this to go away. So all we need to do, so I'm not sure what device you have here. In terms of using the emulator, Android uses something called the AVD, the Android Virtual Device. Now, so what you need to do is you may need to configure using the AVD manager. If you have one, it doesn't really matter what you use. As long as you have some virtual device here, I'm just going to use the default, which is the Nexus 5. As long as you have some device here, that's fine. It's probably a good idea to install at least one phone virtual device and one tablet virtual, so that way you can look at your app on both a phone version and a tablet version. But I'm pretty much just going to focus on the phone. So to try running my app, I'm just going to run it, which will invoke Gradle and start my Android virtual device. So you can use any virtual device that kind of defaults. Okay, I will show you that, Mark. So we can see down here my Gradle build is running. Just bear with me, Mark. If you click on Tools and AVD Manager, there's going to be an option there to install an Android virtual device. I'll show you that in a minute, but I don't think I can do it while my app is building. So you're seeing it that, yeah, so under AVD Manager, thanks Kival, you just go into Create Virtual Device. So you can really pick, I would just pick any of the phones in there. There's Pixels, there's Google Nexus, there's some other devices. So here's my app running. Just displays this hello world text view, a label just in the middle of the device. So under Tools and AVD Manager, if you click on Create, so I've created these three. So you can create a virtual device. So let's see, if you choose, I'll just choose, let's say, a Pixel 2. Yeah, whatever it recommends is fine. If you have one already, installed, you can just select it. If none are installed, you will have to download a system image, and the system images are bigger. Thanks for that, Delano. And again, this is to use the emulator. If you find the emulator problematic and you have a physical Android device and it's easier to just plug it in, then you can just plug it in. Yeah, I think Pi is a good idea. Yeah, R and Q are very recent. I think I would avoid those and go with Pi, Oreo, or Nougat. A couple of warnings about the emulator. It is kind of slow. It's getting better, but it is slow. The other thing is sometimes it will just hang and not refresh, and you have to do a cold boot. Because typically if we stop the app and run it again, when the emulator comes back up, it just hibernates and goes back to where it was. And yeah, you may get prompted to install the hardware acceleration, which I had to do on mine. And when I tried to do it recently, Windows blocked it because my version of Windows on my college computer, it's was set to run Windows Hyper-V for virtualization. So I actually had to disable Hyper-V and reboot my computer before I could update the Intel hardware acceleration. And yes, it will probably recommend allocating, I think, 2 gigs of RAM for the hardware acceleration. Yeah, Delano, it does require a reboot. Don't worry, we're not going to go too code heavy today. Right. Yeah, so Delano, what you may want to do is just follow along for today, and then once you have a chance to reboot your computer, you can do it. Hayden, Kotlin supports hot reload. Yes, it does. Actually, no. Sorry, in Android Studio, you do have to click Apply Changes, and if you add new elements to the UI, you have to do a full restart. You don't have to restart the whole emulator, but it has to reload the app. Mark, I'm still looking at your question. VTX. That may be related to the Hyper-V problem. Let me just check. Okay, Bikramji. Yeah, it is to do with virtualization in the BIOS, but we'll have to maybe find a link on Mark how you enable that. You may have to restart the computer and go into the BIOS settings. Let's just check. It can be a bit of a trick to configure Android Studio once it's working, it tends to work quite well. Right, so this is basically what I had to do was go into the Windows features and disable Hyper-V. That did work for me. We required a restart. So Mark, you may want to try the instructions I just posted in the chat. It will require a restart. So you could do that now, or you could just follow along. Yeah, DuckDuckGo doesn't track you. It's the best browser for privacy. I strongly recommend a not-for-profit browser and search engine, which is why I use Firefox and DuckDuckGo. Okay, Mark, in that article, there's also some other instructions here in the link I posted about modifying the BIOS. So you can have a look at those. I realize you won't be able to do this right now and follow along. But have a look. If you need more help outside of class, let me know and we can look at it together. Okay, so hopefully a few people have managed to get their app running. It's about 1 o'clock, but all I'd like to do, I'd just like to modify this UI really quickly and write like a couple lines of Kotlin code, and then we can call it a day. Okay, so I'm going to go back to Android Studio. And if you'll notice, I'm going to go back to our main activity. A couple things to notice here. So in the design view, our text view, our element here, it's centered horizontally and vertically. If I look at the code window, you'll see that inside, so we've got this text view object here with these XML properties, and this is all contained in a layout called a constraint layout. Excuse me. So the constraint layout is the default layout now. It's new as of a couple years ago. So the idea of a constraint layout is that our layout is flexible. So it allows us to have dynamic UI where we don't have to nest multiple layouts. And it's designed so that if our application is turned or it's on another device, things are still kind of constrained to each other. So it's similar to an older layout called a relative layout. There's other layouts called like a linear layout and a relative layout, but constraint is the default. So we can change this, but this is normally what we're going to get anytime we create a new Android activity. So what actually centers this text view are these 4 constraints. That the bottom is anchored to the bottom of the window, the top to the bottom, the left to the left, and the right to the right. So that's what puts our button right in the middle. So let's say we want to add something above this. Let's say we want to add, if I click on, in my palette, I'm going to click on text. So we actually want a text view where we can type to go above this. Actually, you know what? We want a text box and we want a button. I'm actually going to get rid of this. So I'm going to right click on my text view and I'm going to delete it. Or I could just go into the XML and you could just remove that node. Either one will work. So I'm going to add 2 elements here. I'm going to add a plain text. So this text view, this is basically a label. This is for displaying text. Users can't interact with it. For users to interact, we want a plain text. So I'm just going to drag one of these onto the layout. And notice what Android does. It gives it a default ID of edit text person name, which is a really long name. The Android convention, so over here in the properties window, I'm going to rename this to just edit text name. So in Android, each object, typically we prefix it with the name of the object in camel case, and then a description of what kind of value goes in it. I'm going to call it edit text name, or I could give it an ID in the XML. Now I get this little warning here saying the view is not constrained. So at runtime, it will jump up to 0, 0 unless I add constraints. So it wants us to constrain this view. It'll run. If I run my app, it should run, but our text box is going to appear, our edit text is going to appear up in the top left because we haven't really positioned it. So I'm going to build and run my app. My emulator flashes. And our edit text appears right at the top left. So we want to constrain it. We want it to go horizontally centered and also in the middle. So I'm going to add a few constraints. So there's a couple ways I can do this. In the WYSIWYG editor, if I just click this circle in the top middle, click and drag, this constrains it to the top. And if I do the same, left and right, I've now constrained it and centered it horizontally. Yep, you can use the constraint widget as well. You can also do it in the XML. So in the code, we could just add end to end of, that's the right side, start to start of, top to top of. So there's different ways to do this. So now when I apply those changes, just click this little restart button, apply changes. It should at least move it over central. So now underneath this, we want to add a button. So we want to anchor these relative to each other, that our button will appear below our edit text. So I'm going to click on button. I'm going to drag on click a button. I'm going to add it to my component tree. And I'll just call button I'll call it say hi. So our button also has no constraints. So I'm going to set the constraints on my button, but I'm going to do these in XML. So I'm going to go into the code window. And on our button, I'm going to set up 4 constraints. I'm going to type that the start to start of is going to be equal to parent. And I want the end to end of also to be parent. This will center it horizontally in the middle like our edit text. We want our top to the bottom of our edit text. So we're referencing the ID of the edit text. So this puts the button below the edit text. And then our bottom will go to the bottom of the parent. So this is going to put our say hi button underneath our edit text. So it appears down here. You can play around. You don't have to use the same constraints I'm using, just to give you some idea. So there's no hot reload. I can't just apply the changes because I've added a new object. So I got to restart the app and our button should appear. We're almost done for today. I know it's Friday and it's sunny outside. The problem is I won't keep it too much longer. So I'm going to restart. And now we've got our button anchored below. Now maybe I want to move this name box here. So to do that, I'm going to change my edit text. Instead of being anchored to the top of the window, I'm going to say, I'm going to take out the top constraint and say the bottom of our edit text goes to the top of our button. So now instead of anchoring the top to the top of the parent window, the bottom of the edit text is anchored above our button. And I obviously did something wrong. Let's see. Take that out. I'll put this back for a minute. We'll see what this does. Okay, so it is underneath, but it's anchoring both of them. Okay, that's okay for now. The last thing we want to do is change the text on the button and then write some Kotlin code that will just generate a message. So on our button, notice the text of it says button. So we can change it in the designer through this properties sheet if we want. I click on my button. We can change the text here. However, not advisable. So in my code, so notice what you actually want to do is we don't want to hard code this in. We want to create a string resource. We want to move the text out of the user interface and put it in this strings.xml over here. It's going to have a string. We're going to create a string resource called click me. And Android Studio says, I don't know what that is. That's why it turns red. There is no value in our strings file. There is no key called string name. So if I just mouse over or hit Alt-Shift-Enter, it says, well, do you want to create a string value or string value resource called click_me? So I'm going to choose that. So the value for this is going to be click me. So this is the text that'll appear on the button. So inside of strings.xml, we're creating a key called click me. These should be all lowercase with no spaces, and this will be the value. So now the red goes away, and in my strings file, it's added a key called click_me with this value. So I want to change the text on the button. I change it in strings.xml. I don't change it in the layout file. So now I'm going to run the app again, and our button should say click me. Good question, Kartik. We can change it in the layout file, but there's a couple of drawbacks. Number one, by using strings.xml, all of the text content in the app is in one location. So if we want to make changes to like messages and things, we only have to change one file. The other value, by having the text dynamic, this supports multiple languages. That's right, Hayden. So if we want to make our app available in French, in Punjabi, in Korean, we will create like a French strings fr.xml where we could put all of our French text. And that way, none of the text is hard-coded into the UI, into the activities. So it's much easier to support multiple languages. Does that make sense, Kartik? No, it doesn't. But it's the other way around. If we change strings, it updates the activity automatically. So the activity reads, it's basically a variable. So it reads the variable from the XML file at runtime. So now our button says click me. So if let's say I add some exclamation marks to my strings.xml, I can just restart the app and the text on the button should now have 5 exclamation marks. So we're separating the text, the content from the layout by using the resource file. So now we get these extras. Okay, so the last thing we'll do is we'll just write a really simple click handler where we can take the name and just display a little pop-up message when the user clicks the button. So these elements, every element, Android has this weird name for the individual UI components. They're not called components, they're not called elements. Android calls each one of these objects a view, which is kind of puzzling language. You know, we're used to MVC architecture where we think of a view as a whole screen. You know, what Android would consider an activity. In MVC terms, we call that a view. But Android calls each individual object within an activity, each visual element is known as a view. So this button is a view, And this edit text is also a view. And again, that's one of the questions in next week's quiz. So I'm going to try to use that terminology of a view. So a view means one object on a form. It is not the whole form or screen itself. So now we're going to go to our Kotlin file and we'll just write a really simple click handler. And we'll call it a day. So I'm going to go to my Kotlin file. And inside our... Yeah, absolutely. We will do that. We'll look at navigating, Andrew. We're not going to do that today, but we'll look at absolutely how we navigate for sure. We'll be doing that. So all we need to do is write a simple Kotlin click handler. So within the onCreate method, we are going to create a button onClick handler to display a message. So what we want is to set an onClick listener for our button. Now, it says it doesn't recognize the button. So if I just click it, let me just, did I call it? But oh, whoops, wrong name. I did name it something else. So button say hi, so it already recognizes it. So I'm going to set an onClick listener in here. So first, get the name entered in the edit text. So we'll just use val. I probably should have called these say hi button and name edit text. I'll change those next week. The view type should go at the end. So I don't need a semicolon at the end. I'll create a message variable. You can put the semicolons in, but you don't have to. So now to display a message, sorry, the it view, Shaista, where do you see that? I don't see where you're having got. Oh, no, that's just a code prompt from JetBrains. So this code, we see it's got this little gray background. That's just a code prompt. Yeah, so it's automatic. So Android has this object called a toast. A toast is just a message that pops up, a little pop-up window here. So we're going to use the toast to show a message. So we'll call toast, which is an Android widget. We're going to call the make text function. It takes 3 parameters. The first one is the context. So what Kotlin or Java object is displaying the message. So we can just use this that refers to our main activity class. The text of the message, which is our message variable. And then we have the duration. So how long do we want to show it for? So there's a long display and a short display. You can pick either one. I'll pick a long display, which is just an enumerator, and then we call .show. So this should take whatever gets typed in the edit text and display a little message that says hello. So I'm going to run these changes. I can hide the keyboard with this little down arrow. And now I get my toast message showing for about 5 seconds, 3 seconds down at the bottom. The toast, I don't believe you can reposition. There is another kind of message called another messaging object called the snack bar, and that appears somewhere else. I think the snack bar messages may be at the top of the screen. Haven't used them for a while, Andrew. So whatever I type here, and you may have to hide the keyboard. The snack bar may be at the bottom as well. So our code's very lightweight, no semicolons, and we'll use the toast for simple outputs a lot. Yeah, it's sometimes though the keyboard hides it. So if you bring the keyboard up and click, the keyboard actually hides the message. So you do have to hide the keyboard in order to see it. Yeah, that might be on your phone. Andrew, does it say which line? So that's, Andrew, I will come back to your question and I'll help you debug it. Okay. So if you've got this working, that's great. That's really all we wanted to do for today. So if you have this working, then we're done for today. I did use double quotes for the message, yes, because I've got the string variable inside. If you're using single quotes, I believe you'd have to append the message outside. So remember, I did have one other kind of activity plan, but I think we'll call it a day. I'll move that activity to next week. So the only thing you have to do for next week is complete the quiz. As I said, I suggest you do it sometime next week, just before 5 p.m. on Thursday. So that Miro board I invited you to, we'll use that next week. Don't worry about it for this week. We'll move that to next week. And also start thinking about what kind of app you like to build. And I will give out that assignment next week. Okay, and I will stick around in the WebEx room if anybody has questions or needs some help. If you've got it working, then have a great week, and I'll see you next Friday.